Hey everyone, this is Dr. Walker. This video we are going to do the example from video 229 on resistance and resistors. Here's the example. It says a car headlight filament is made of tungsten and has a cold resistance of 0.35 ohms. If the filament is a cylinder 4 centimeters long, it may be coiled to save space. What is its diameter? And it gives rho for tungsten. So the first thing I'd like you to do is write down your givens. So pause the video, write down your givens. So the givens are the resistance here. It says cold resistance, and that's just because resistance is affected by temperature. We'll see that very soon in a future video, but all we need to know for now, that's just a resistance, 0.35 ohms. And then we're given the length. So the length is 4 centimeters, but hopefully you converted it to meters. So divide by 100 to get 0.04 meters. Everything should always be in the standard units. And then we are given rho, which is the resistivity. So 5.6 times 10 to the negative 8 ohms times meters. And when you write your givens, you should always write down what you're looking for, which in this case is the diameter. So now I want you to think, okay, well, what equation is going to be relevant here? So what do you think? So hopefully you came up with R equals rho L over A. This gives us the resistance of a resistor, a cylindrical resistor. Now this equation has area and not diameter, but the diameter and the area are related. Can you figure out how the area and the diameter are related? So the way that the area and diameter are related is that the area of a cylinder is a circle, so the area of a circle is pi r squared, and then the diameter is twice the radius, so d equals 2r. So if we know the area, that can be our unknown because we have all of the other givens. If we know our area, we can solve for radius. Once we have radius, we can solve for the diameter. So that's our steps. Let's go ahead and solve the problem. First step is to solve for area. So area equals rho L over R. Plug in the numbers, 5.6 times 10 to the negative 8 times 0.04 over 0.35. That gives us an area of 6.4 times 10 to the negative 9 meters squared, if I have that correctly, yes. So now that we have our area, let's go ahead and solve for our radius and then our diameter. So our radius is going to be r squared equals a over pi. So r is going to equal to the square root of r squared, which is the square root of a over pi. And then let's just go ahead and do the diameter is going to equal 2 radius. So it's going to equal 2 times the square root of our area over pi. So we go ahead and plug in our value for area that we found under the square root. Divide that area by pi. Take the square root and then multiply by 2. Final answer for the radius is going to be 9 times 10 to the negative 5 meters. So this was an exercise in using the resistance equation, but also realizing that the cross-sectional area of a cylinder is a circle and being able to use the equation for the area of a circle. That's it, everyone. See you soon.